Yeah. So hello guys. Hey everyone. I hope that I'm live right now and you all are able to see me and the screen as well properly. We will be starting in 5 more minutes. I'm just waiting for everyone to join so that if someone is a little bit late, we can get started. The topic for today's discussion would be neural networks and deep learning. Today we'll try to understand how neural networks and deep learning actually work because it is very important for us to do so, because the entire concept that we are going to learn, that is computer vision based on convolutional neural networks. So understanding of neural networks and deep learning is very important for you to complete the project as well. So yeah. Okay. The session would be at the same timing from 8:30 itself, because we also have to work, and after work we come back home and then we do all these sessions. So that's the thing. Okay. We'll just wait for 5 more minutes so that everyone can join and then we will get started. Okay. uh yeah. Okay, so I will just open up the session live chat on my screen as well so that I'm able to see you guys. So just a sec for that. Okay, so this is the live chat, I presume. So I guess this should work. Okay. Yeah. Just open it up right over here on my screen. Okay, so the attendance link for yesterday has been closed right now. Okay, we will be sharing yesterday's course material on the WhatsApp group, Telegram channels. You can download it from there. After this class, I will be sharing yesterday's class material on those channels. Okay, so that's one of the thing. I don't think so more people are going to join. We will get started right now. Uh, like I said, the notes will be provided today after this class. For yesterday, I will be putting it up on all the WhatsApp groups as well as the Telegram channel. uh, See, for the attendance from today onwards, I'm not going to tell you guys anything. I will show the attendance link anywhere in the middle, in the start, or in the end of the entire session. At any point of time, I will just open the attendance link for just 30 seconds, less than 30 seconds. The attendance link would be seen on my screen, and after that I will just like remove it. So you will have 30 seconds to take the screenshot. Of course, for those who are not watching it live, can come back later, watch the session and get the link. So yesterday I gave you a lot of time, I showed you the link, and now you understand that the attendance link always works. There is not a single scenario in which the attendance link is not going to work. Every day there will be a new attendance link, and if you are missing out on an attendance link, the chances of you getting a certificate is really low. Okay, so attendance is very important, guys. Yeah. Okay, so let's get started. I guess like more people are not going to join, and if they are joining they can like just rewind and just watch it again. Okay, so let's get started. For attendance, we have the attendance link that will be shown on the screen just like the yesterday's session. You have to take a screenshot for that attendance link. Today the attendance link will be on the screen for just 20 to 30 seconds. So if you are not watching the entire session, if you are not learning and you're just here for the certificates, then your like probability of you getting the certificate is really low. Okay, so you have to pay attention to what I'm teaching as well. The final registration form was not important to fill. Of course, it helps us to reach out to more number of students as well. But yeah. Okay, so let's get started, guys. Just move on to the screen. I guess this should work. Just a second. Okay, so for yesterday I have closed the attendance link. Okay, for today there will be a new attendance link that will be shared. Again, the attendance link will be shared any point in the middle of the entire session, and it will be shared in such a way that you will have almost 20 to 30 seconds itself to take the screenshot. And this is YouTube, guys. You can rewind the video, pause the video, so don't say that I missed it or something like that. Okay, today we will be covering the theory for deep learning and neural networks. So that is the second day. On the day 3 and 4 we will be covering the theory for computer vision. On the day 5 and 6 we'll be covering hands-on like Python, like we'll be writing code in Python and everything, understanding Python from scratch. On the day 7th and 8th, okay, we'll be doing the entire project of computer vision that you can put up in your resume as well. So that project will be on such a basis that you can put it on your resume, so you don't have to worry about it. It's a good project. Okay, so let's get started, guys. I will just take this up on my screen, and that's all. So let's get started. Okay. So sometimes I feel social media, I don't know, like what about you guys? You guys are in your like college itself, most of you guys, I hope so, that you are currently in your college, and hence you don't like understand that you are on a social platform. You should understand this very clearly. uh, Otherwise, like whatever you are writing on a social media platform, in some way or the another, if it gets connected back to you, it will harm your own reputation itself. So you need to understand that as well. Okay. Okay, so what is happening right over here? I'm not able to connect. Yesterday we got 4,600 people who filled up the yesterday's attendance. Okay, so 4,600 people almost. So what's your name? My name is Shaurya Sinha. Okay, I previously worked at Shape AI as a machine learning engineer, as a data analyst, as a software engineer. I worked at various companies as well as intern as a data analyst as well. So that's the thing. You can check my bio on LinkedIn as well. So you can just search for me on LinkedIn and you will be able to see it. Guys, think so. This is not working. I don't know why. Just give me a second, guys. I'll just refresh it. Okay, so it gets connected. Let's see, if a particular person, we will consider for Shape AI certificate, we will consider even those people who have at least 6 days of attendance out of 8 or 7. Okay, but for the AWS certificate, that is given by an entirely other body. Okay, that is AWS Students Club. So for getting that certificate, you need to have 100% attendance. Otherwise, you will not be able to get the certificate itself. So let's get started with neural networks. Okay, very important topic, guys. Please understand this. If you don't know this like topic, it will be very harmful for you in the future. Okay, so let's get started. Yesterday we talked about machine learning. We understood what machine learning is. We understood the basics of machine learning. We understood what is the core essence of machine learning. Today we will be diving deep into a subcategory of machine learning itself. So machine learning has many different algorithms associated with it. Just like AI is there, okay, under AI you have machine learning. Even machine learning have many algorithms and sub branches that are present. One of those algorithms is neural networks. Okay, also called as neural nets. This is one of the algorithms of machine learning, and neural networks come together to make a new branch, a new subcategory of machine learning that is like the on its peak right now. So there are so many algorithms in machine learning, but you will find it very common that all the applications that you use, from Netflix recommendations to Google search results to like Google Lens or your Alexa, okay Google, Siri, all use just one kind of machine learning algorithm the most, and that is deep learning. Today we will try to understand the mathematics as well as the like background behind deep learning, try to get the core essence of these algorithms that are being so famous right now that almost every single company, even from a small startup to large companies like Microsoft, Google, are expecting their students to learn. Okay, so we are going to like just start with this. Okay, so getting started with neural networks. So the history. So first let's discuss like from where did neural networks come in, what was the history and everything. So neural networks was inspired in the early 1940s by researchers who tried to implement some of the ideas of neuroscience to computers. Now yesterday, if you remember, I had said to you that most of the algorithms that are being developed and used in machine learning usually come from researchers looking at nature, because it's a human tendency to mimic what is happening in the nature itself. So one of the main things, like main branches that the scientists and researchers focused upon was neuroscience. Okay, so neuroscience became very important. Just a second. Neuroscience became very important for these researchers in 1940s. So what they tried to do was, you have your human brain. Okay, so this is the picture of the human brain. Very bad picture, but like I hope that you are able to understand that this is the human brain itself. Okay, so this is the human brain, the most intelligent part of the entire human body, because this is where all the processes that happen in your body, whether it be you thinking or your like entire organs work. Okay, this is very important for you to know. Okay, like how does the human brain function? And at that particular point of time, researchers had some idea that the human brain consists of neurons. You must have learned about neurons in your biology classes when you were kids, maybe in your 6th, 7th, 8th, or ninth. This is something that is covered by all the CBSE, then whatever other branches are there. Okay, so neurons were a sub module of the brain where most of the decision making took place. So what did these like researchers do? So you are having your neurons, okay, that are present in the brain. This is something that exists in the nature. So what did the researchers do? The researchers tried to mimic, tried to create, tried to make an artificial neuron using what? Maths. Using mathematical formulas, using many different mathematical ideas and ideologies, they tried to mimic, tried to create an artificial computer based neuron. And this was done in 1940s. But deep learning became very important around I guess around 2001. Okay, so even though deep learning neural networks itself was found in 1940s, and there are some studies that show this type of research being going back to the 1900s as well, still the more essence, like the more usage of neural networks came in 2001 after almost 60 years. Why is that so? We will try to understand in this particular today's session itself as well. Okay, so this was a little bit behind the history. We will discuss about it a little bit more. Okay, commonly used in, so where is neural networks, deep learning commonly like used in? Okay, so CNNs are commonly used in image search services. For example, your Google Lens, you are looking at a particular product, it is showing you that, okay, this product is basically a shoe. You can find the information of this product somewhere else. So your camera lens is able to detect that a particular object is a shoe, or a particular object is a laptop or a mobile phone or a TV. So there the entire machine learning model, that is the neural networks model, is able to find out what that object is just from the picture itself. Okay, so and then like you are having your self-driving cars, for example Tesla. So in Tesla, 90% of developing the cost of the Tesla itself is just the software that the Tesla is using. Okay, that is entirely made using neural networks and deep learning. Okay, your recommendation systems, for example your Google, Netflix, all these recommendation systems are also built using deep learning, fraud detection, and many more systems. Okay, they're also used in other successful tasks such as voice recognition, natural language processing, and so much more. So hence learning neural networks become very important for you to understand, then only you will be able to move forward actually. Okay, so let's try to understand how these people mimicked the entire neural network. Like how did they create artificial neural networks? What did they saw in these neurons in the human brain that they modeled it after maths? Okay, so someone asked in live chat that why are we learning the history behind it? Because Shape AI is not interested to make you great data analysts. They are not interested to make you the best in the world. Even the best people in the world sometimes do not get jobs, and I don't think so you are here to like make the next Tesla. You are here to get a job. So we only teach that much which can be asked in your interviews. And to understand the core essence of why you are learning neural networks, you need to understand why they were created, what was the ideology, what was the maths behind it. Only then you will be able to understand that topic as well. Otherwise you can just take a book and just memorize everything, just like the machine learning models that are overfitted. Okay, so you need to learn, understand, that's the main point of learning. Okay, so let's try to understand what happens in the brain itself. All these researchers actually found out. Okay, so you are having these neurons. Okay, you are having, sorry, yeah, you're having these neurons that are present in your brain. Okay, you are having these I think so these are called as dendrites. I don't remember. Okay, so this is where the signals comes in. Okay, I just need to search for it, I guess. Like just a sec. Okay, so you are having these like neurons. You are having three parts of the neurons. First, where these signals are intercepted by the neurons, that will be this entire part. Okay, I'll just highlight it. Okay, these part, the one that I've shaded in red, is where the signals come into the neurons. Okay, in this is the nucleus of the neuron where the all the decision making takes place. Okay, this is the computational part of the neuron itself. These signals then get transmitted through the axon, and then through these dendrites it gets transmitted to the next neural net itself. Okay, and as these are connected to thousands of different neurons, hence it is called as a neural network, because there is a network, they are interconnected to each other. So what did the researchers do? Okay, you are having this neuron, okay, nucleus. Okay, this nucleus is where all the computation takes place actually. This highlighted area that is present right over here, the main function for that is to take input. Okay, the main function for that is to take input. It gives the input to the nucleus of the neuron, and then using the axon it is then given out as output. Okay, it is then given out as output. So you are having your output. So this is the entire model, so simple. Okay, just by understanding how neurons work, these researchers were able to create an artificial representation of the neuron itself. that here there will be some mathematical function that will be doing the computation, taking in some inputs and giving us some outputs. Okay, so let's try to understand. Neurons are connected to and receive electrical signals from each other neurons as well. So like I've said, electrical signals come in to the neuron. Okay, these can get like these electrical signals are just ones and zeros. Okay, because electrical signals are present in that particular way. These get computed in the nucleus and then it gets transmitted via the axon to the next neuron where some other computation takes place. Okay, so these are neurons are connected to and receive electrical signals from other neurons. Neurons process input signals and can be activated. So for a particular neuron, it may be present that okay, whatever electrical signals that that particular neuron has gotten, it is not doing any computation on that, it is just passing it along. So that means that that neuron was not activated, that is, it is deactivated, that there was no computation done on that particular electrical signal. Okay, so then these questions arise, can we take this biological idea of how humans learn, because humans learn via their brains and their brains are comprised of these neurons, and apply this learning that the researchers took into machines as well. That is something that we need to understand. Okay, then came the idea of artificial neural networks, the mathematical model for learning inspired by biological neural networks. Okay, so from what we learned from our brain, okay, what we saw in the biology of the human mind, we took at it out, we created a mathematical model that is capable enough to learn. Okay, and this is that has been inspired by the biological neural networks. Okay, so artificial neurons, let's look at the neural networks, that is what we are here to study. Okay, mathematical functions from inputs to outputs based on the structure and parameters of the networks. Okay, so let's try to understand it. Just like I said, so this entire nucleus, what we represented as nucleus, will be now like said as a mathematical function. Okay, it's a function. Okay, it's a mathematical function that takes in some input and does some mathematical formula. We'll be looking at what the mathematical formula is. It does some mathematical formula taking in this input and gives us an output. Okay, this output can be a desired output. This output can be something that we can use again as an input to another neuron to give us another output. Okay, so we can even take the output from one neuron, feed it as an input to another neuron to give us a third output. So we can increase the complexity of these like neurons passing in the input and output to each other and back and forth to create a very complex mathematical formula that a single neuron is not capable to do. So like it's always said that if you are working together as a team, you will be able to do that even complex stuff in a very short amount of time. The same thing applies to artificial neural networks as well. As you're able to see from this particular example, okay, as you're able to see from this particular example itself, this is the input layer. This is the input. Okay, I'll just remove this particular part. Okay, this is the output, and this is the entire neural network layer. Okay, this contains the neurons. These are the neurons that are present. So what is happening is these neurons take in inputs. Okay, from these inputs they take in inputs, all these inputs are fed into these different neurons. Okay, these get all these inputs, they take these inputs in, they do some complex mathematical formulation that we will see when we go forward, and then they give out some outputs, and these outputs come together to give us the output layer. Okay, we will be looking at how this works in the future, like in the next few slides itself, so don't worry about it, just giving you a brief introduction of how it looks exactly. Okay, allows for learning the neural networks parameters based on data. Again, this is related to machine learning, as artificial neural networks is a part of machine learning. It is highly dependent upon data. Okay, it learns from the data itself, so that is also very important for you to understand. Okay, so biological neurons are, yeah, just like biological neurons are connected to each other, passing in the electrical signals, in the similar way the neuron on units, okay, these were called as neurons or units. The representation for these biological neurons are called as neurons or units. Okay, these neurons can also be connected to one another. Okay, just I have already said that the input to the first neuron will give us some output, and this output will now become the input to the second neuron to give us a final output again. Okay, so this is also very important to understand, okay, that these neurons can be connected. So if it is doing f of x, this is the function, so we are getting an input x, we are doing f of x, and this will be the output. This output becomes the input to the next neuron, that is g of f of x. Okay, so if this is a function of f and this is a function of g, then the output would be g of f of x. So you can see how the complexity of the output increases. Okay, what is the time complexities and space complexities for this program algorithm? Tax 3R, when we are moving forward, you will be able to understand that in these algorithms you do not see these algorithms with respect to time complexities or space complexities, because it takes both of them on a very large level. So usually people are not at all like they are not even considerate about the time complexity itself. To enhance the time complexities, the best you can do is to buy more better resources, a workstation, a more powerful workstation to do the computation. So people do not care about the time complexities and space complexities in these problems. Okay, so that was the basic idea, okay, behind neural networks. Let's try to understand how these might be used. Okay, so using some input attributes predict the death in Titanic. Just taking an example. Okay, so for example, you have a database, you have a data of the people who were traveling in Titanic. Okay, so Titanic was a ship that sank. Most people know about it. If you don't know about that as well, then you are really, like, I don't know where you are living, guys. Okay, so Titanic was a very big ship that sank. Okay, so you are, and many people died. Like, it's very really bad thing, but yeah, many people died. So you want to create, okay, you are having the data that whether that particular person on all, of all the people on Titanic, you have a data. Okay, so you have having data, for example, what was the age, what was the gender, okay, whether he was male, female, what was the compartment in which he was living, okay, whether he was first class, second class, third class. Okay, so that is also something that is given. So there is a lot of data that has been provided, and an output value has been provided whether he lived or died, okay, by 0 or 1. Okay, 1 predicts that he lived and 0 predicts that he died or she died, or like the kid died. Okay, so that is what has been given to you as a data. Now what you have to do is you have to take in this particular data and predict. If you are given the age, gender and class of a certain individual, you have to predict whether he would have survived. So for example, if I'm giving your data to this particular algorithm, machine learning, deep learning algorithm, it should be able to predict whether you would have survived the Titanic or not. That is your main aim. Okay, so in the form of the input, you are having these age, gender and class. Okay, so let's take age and gender itself. Let's just remove class for now. So you are having two inputs, age and gender. So we will take age as x1 and gender as x2. Okay, so you want to take in these x1 and x2 and predict 0 or 1, okay, whether you would have survived or whether you have died. So that is the problem statement. Okay, so what can you do about it? In order to determine this hypothesis function, we need to determine what these weights should be. Okay, so you need to find out the output, that is h of x1 comma x2. This is the output that you are going to get. Okay, it should be like whether you survived or died. Okay, so 0 or 1. okay, whether you survived or died. Okay, so you will take in these inputs x1 and x2, you will create a particular formula, okay, very simple, of two variable line, okay, so that is the entire formula, not a line, a plane, okay. So you are having this particular formula, okay. So what is this formula? Basically a simple formula. So you are having y is equals to mx plus c, okay. This is the formula for a line. This is basic 10 standard mathematics, okay, basic 10 standard mathematics. So this is the formula for a line. Now if I'm having two variables, this is a like in two variables, that is one is output and one is input. Now I want to create a like thing in three variables, that would be a plane. So y would be equal to ax, y would be equal, just a second, y would be equal to ax plus ax1 plus bx2 plus c, okay. This is the formula that you will be using, okay, to get the y value. So a can be anything, b can be anything, c can be anything. You are having x1 and x2, okay. So what you are having x1 and x2, you need to find out the values of a, b, c. You want to find three values, that is a, b and c, that will satisfy this particular equation, so that you can be easily able to get y, that is 0 or 1, that is your output, okay. So hypothesis function is something that, what is the meaning of hypothesis? That I think that this particular function should work, that is the hypothesis, okay. Now to make this hypothesis a reality, I need to find out these values w1, w2 and w3. Okay, I think so most of you are not able to understand this, because like again, just like I said, I don't go very fast, otherwise I know that 90% of you will not able to understand it. Okay, so just let's take in some easy example. Okay, so let's do one thing. Let's change the problem statement entirely, so that you guys are able to understand it in a much more easier sense. Okay, so you are okay, let's just cross it out, okay. Another new problem statement just made for you guys, so that you guys are able to understand it. A very simple concept of OR gate, okay. OR gate, very simple. You are having your two values x1 and x2, okay. The value of x1 and x2 can either be 0 or 1, okay. So you are having your 1 1 0 0 1 0 and 0 1. These are all the values that are possible for x1 and x2. X1 and x2 are two values, okay, that can either take 1 or 0, okay. And you are applying the OR gate. For those who don't know OR gate, like it is basic 10 standard physics, okay. In electricals you must have learned it. If you don't know that as well, then you are in deep waters, man. You shouldn't pursue computer science itself, like I can bet on that, okay. So x1 and x2, so what does an OR gate does? You will get value as if one e if even x1 or x2 is like if x1 or x2, even one of that is 1, then the output would be 1. That is the condition for OR gate, okay. So you are having 1 and 1. A simple definition for OR gate: even if one of x1 or x2 is 1, okay, even if one of them is 1, then you will get the output as 1. So here x1 and x2 both are 1, so the output would be 1. Here neither x1 nor x2 is 1, so you will get 0 as the output. Here only x1 is 1, yes, one of them is 1, so you will get 1 as the output. And then you are having x2 as 1, so as one of them is 1, it is simple, 1 will be the output. Very basic stuff. I think so everyone should be able to understand this example, okay. I hope that everyone is able to understand this, because now it will become very easy for you to understand the entire deep learning in very basic sense, okay. So this is the data that we are going to consider. Our goal is to create an artificial neural network, okay, that can take in x1 and x2 as input and give us the value y. That is our entire like goal for today, Okay, very simple. Okay, so this is the data that we are going to use. Let's try to model it. So let's take up a blank page. I presume that would be better for you guys to understand. Okay, so OR function right over here, I have taken up the example. So this will be 0, this will be 1, 1, and this would be also 0, 1. Okay, so this is the entire example that we are going to take in. So what will happen? So let's take up an example. Okay, let's make okay, just let's go to another page itself where there is some. Okay, so you are having two inputs. Okay, so you will have two input neurons. Each one will get x1 and x2 as their value. Okay, each one would take x1 and x2 as their value. Okay, and then you are having a computational neuron. Okay, this is the computational neuron that is present, and then you will get the output. So this is the entire network that we need to use. So x1 can take up values of 1 and 0, and x2 can also take up values of 1 and 0. Okay, so when these values are being passed to this particular neuron, so this neuron is getting, for example, first we are going to take 1 and 1 as inputs. Okay, so we are going to take 1 and 1 as inputs. So you are getting 1 and 1 as inputs to this particular neuron. Now what this neuron does? Okay, this neuron will take up a formula. Okay, this formula is called as the hypothesis function. Please understand that this will be the formula that you will be working with. Okay, the entire going further, you will be working with this entire formula itself. That is h of, okay, let's now, I will not complicate things. For those familiar with 10th standard mathematics, a function can be represented as f of x1 comma x2. This is how a function is represented. Even 9th standard people know this. Okay, is equals to, let's take up some arbitrary variables. Okay, a of x1 plus b of x2 plus c. Okay, this is the entire values. Please use white color. Okay, sure. Okay, so f of x1 comma x2 is equals to a of x1 plus b of x2 plus c. Okay, now this is the formula that we are going to use. Here x1 is 1, x2 is 1. So what will this particular formula give us? A of into 1 plus b into 1 plus c. That is a plus b plus c. Now I need to get an output as 1. Okay, that is our main goal. Okay, I need to get output as 1. Now what I'm going to do is I'm going to give you the values of ABC right now. Okay, I'm just going to give you the entire process of calculating these values is the entire crux mathematics that works behind these neural neurons. Okay, but just to make things easier for you, I'm just going to give you the values. Okay, so the values are going to be 1, 1 and minus 1. Okay, that is the values. I have provided you the values, guys. I have provided, so the value of A is equals to 1, the value of B is equals to 1, and the value of C is equals to minus 1. Okay, so here the value of this particular thing is 1, the value of this particular link is 1, and here again another value is being passed, that is minus 1. So this is the entire neuron. So whenever I am passing 1, so what will this particular function become? This will become 1 plus 1 minus 1, and that will give you 1 itself. So when 1 and 1 is passed, you are getting 1 as the output. Okay, next, this I have provided to you. The values of A, B and C are being provided for you. Okay, is this course beneficial for cyber security? If you are in your first year or if you are in school, then you shouldn't waste your time thinking about cyber security. There are no jobs in it. Okay, in India you will not be able to get any jobs in cyber security. Okay, currently from this particular YouTube channel we are making $20 a month. $20 is less than what I'm spending every single day on my Starbucks coffee. Okay, so like it's of no use to us. Okay, so that's the thing. So I have provided you with the values of A, B and C. So let's replace it right over here with the values. A is 1, so x1 plus B is 1, so x2 minus 1. So this is our formula. So f of x1 comma x2 is x1 plus x2 minus 1. Okay. So that is the entire thing. Now that you have got this entire value, you need to understand that when what happens when we pass 0, okay, 0 and 1, okay, so this becomes 0, this becomes 1. When passed through the entire equation, it becomes 0 plus 1 minus 1, that is 0. So when we are passing 0 and 1, I'm still getting 0 itself. Okay, I'm still getting 0, I'm not getting 1. For OR gate, we need to get 1 as the output. So what we are getting, let's just like plan it. Okay, so we are having your x1, x2 and y, the y dash. Okay, y dash is the value that we are getting from the neuron itself. Okay, so we are getting x1 was 1, x2 is 1, we are getting 1 as the output. If x1 is 0, x2 is 1, we are getting 0 as the output. Then we are having x1 as 1, x2 as 0, we will get, what will be the output? 0 again. And then if we are having 0, 0 as the input, then what will happen? So if x1 is 0, x2 is 0, we will be getting minus 1 as the output. So this will be minus 1. Okay. Now what was our desired output? Our desired output y was 1, 1, 1 and 0. This was our desired output. Okay, so you guys are able to see that what happened when we pass this data from the neuron itself. Okay, so again please, okay, so again I'm just explaining it to you. This entire neuron, the value obtained from this entire neural network is called as y dash. Okay, this is y dash. Okay, this is the function f of x1 comma x2, that is equal to y dash itself. So y dash is equals to f of x1 comma x2, which is equals to x1 plus x2 minus 1. Okay, this is the entire function. So you're getting x1 and x2 as the input, and you're getting y dash, that is f of x1 comma x2 as the output. Okay, so the output that is we are getting when passing 1 1 is 1, 0 1 is 0, 1 0 is 0 and 0 0 is minus 1. Very easy, just like see what I'm doing. Okay, very easy to understand. There is nothing new, like this is very important for you to understand. But okay, so then we are getting y. Okay, just a second, guys. Okay. Okay, so this is what we have practiced, but we want to get y as the output. So just let's move on to the next like part. Okay, just let's move on to the next part. So we are x1, x2, y dash and y. So we are getting 1 1 0 1 1 0 0 0, and we were getting 1 0 0 minus 1, and we want 1 1 1 and 0 as the output. So what can we do? Can we do some changes to y dash? So y dash was f of x1 comma x2, which was equal to x1 plus x2 minus 1. Can we apply a function and another function on this f of x1 comma x2 that takes in the output, that is f of x1 comma x2 as an input and gives us the desired output? Okay, that is called as the activation function. So a neuron has two parts. One is this hypothesis function. This is called as hypothesis function. Okay, this is called as a hypothesis function which does the basic calculation, that is the mathematics. And the second is called as the activation function, which is represented by G. Okay, this is represented by g of x, and this is usually represented, the hypothesis function is usually represented by h of x, but for your understanding I have just said it to be f of x. Okay, so very easy to understand. Activation function would take in g of f of x1 comma x2. Okay, so just think about a neuron as two parts. The first part itself is the hypothesis function and the second part is the g of x. So this will get inputs x1 comma x2, which will give out some output, that is f of x1 comma x2 would be the output, which will then be taken as an input, okay, to get the final output. This is what we are aiming for. Okay, so what is this activation function? Let's just see. I've just made some graphs for you guys so that we can discuss about different activation functions, and at the end I will be asking to you guys what activation function should we use for this particular OR gate problem. Okay, the first and the most basic activation function is the step activation function. Okay, so what happens in a step activation function is you are having your entire, okay, I'll just change the color. Okay, you are having your entire different like weights, okay, that is a comma b comma c, okay, that can be represented as w1, w2 and w0. Okay, these are the actual representations, and these numbers that was 1, 1 and -1 are called as weights or parameters to a like neuron. Okay, that is something that you need to understand. Okay, so what happens is you are having your, it can be put up in an like w1, w2 and w0. So, okay, most of you must not know matrices itself, so I'll not go into matrices, but try to understand it as x1 w1 plus x2 w2 plus x0, the same thing that we did. This is the h of x1 comma x2, also called as the hypothesis function. Okay, this is the input. Okay, this y dash is the input that we are going to give to this activation function. Okay, this is the input that we need to give to this activation function. Okay, so what does the activation function does? It takes is in the input. Okay, it takes Python is going to start from, again I'm saying Python is going to start from the 5th day onwards. 5th and 6th day we will be looking at Python itself. First you need to understand the basics, only then you will be able to write the code. Okay, okay, so that is the input that you need to give to the step function. Now what is the step function? Let's look at the graph. Okay, this graph is the actual representation of the step function. Okay, you given the value of, so this value, okay, I'm representing it as w dot x. Okay, this is the like for math, I've used this particular slide just for those who know mathematics, so I'm not going into it. Just like think of it as this y dash. So for example, the value of y dash is 0. Okay, the value of y dash is 0. So where will 0 lie on this entire scale? 0 would lie right over here, and the value of 0 would be 1. Okay, so if y dash is passed to a g of okay, so g of y dash and y dash is 0, that will give us 1 as the output. What if the y dash is 1? Okay, any value of y dash greater than 0, 0 included, will give us the output always as 1, and any value of y dash less than 0 will give us the value as 0 always. Okay, this value can be anything. You can just tweak the entire step function to be able to understand it. Okay, so that's the entire thing. Okay, so try to understand this, very important guys. What is a step function? Step functions taken the output from the activation function itself and gives you an output. Here the step function actually takes in the value, okay, and then if the value of f dash is greater than 0, in that particular case, or greater than any particular number, okay, this can be any particular number, you just have to add that particular number into the entire thing. So the value of y dash is greater than 0, it will give you 1 or some other number as the output. Okay, that can be also tweaked. And then if the y dash is less than 0, in that particular case it will give you 0 or any other number as the output. Basic mathematics. Okay, basic mathematics, there is nothing else. Okay, okay, you need to, okay, so this time the, okay, Let's try to understand it one more time. Okay, so g of x, the entire function is represented as this. Okay, if g of x is equals to 1, if x is greater than equal to 0, if the value of x which we are taking in as input to this particular function is greater than or equal to 0, that is, it is lying right over here on the x-axis, in that particular case you will be getting some value as the output. Okay, that value would be 1. Okay, as you are able to see on the y-axis. Whereas if the value of x that we are taking in as input is less than 0, in that particular case you will be getting 0 as the output. Okay, simple activation function. So this activation function takes in the value from x1 comma x2. And okay, so next is the sigmoid function. Okay, so the sigmoid function is basically this entire function f of x is equals to 1 upon 1 plus e to the power minus x. Okay, this activation function is another activation function. This is usually used in case where you want to find the probability. Okay, you are getting an input from f of x1 comma x2, you are taking that particular input to another function called as this activation function, and in this activation function you are able to get the probability. As you are able to see, this the value, the output of this particular activation function lies between 0 and 1, and it can take any range of values. Okay, unlike the step function where you can either get 0 or 1 as the output, usually taking this particular activation function in classification tasks. Okay, for example, our like Titanic data set, where you wanted to where they wanted to understand whether the particular person died or lived. In that particular case you are having two categories, that is, if he died then that is 0, and if he lived, that is 1. Okay, in those cases you will be using step function. Okay, whereas if I am changing the question to what is the probability of a particular person dying on Titanic, in that particular case you will be using sigmoid function, where you want to give a large variety of values based on your output of f of x1 comma x2. Okay, and in that particular case the value can be 0.5, it can be 99, 0.99 is the probability out of 1, and that is all the different things that are there. Data scientists do not come up with these sigmoid functions. These are present in mathematics, and they use mathematics to move forward. Okay, then another activation function is the ReLU function. These ReLU functions are usually used to predict prices of a particular object. Okay, so here if the value of f of x1 comma x2 is less than 0, in that particular case the output would always be 0. Whereas if it is greater than 0, then it is like f of x is equals to x. Okay, so y is equals to x is the line, and that particular whatever the value that we are getting from f of x1 comma x2, if that is okay, so if it is greater than 0, in that particular case we will be able to get the output as f of x1 comma x2 itself. This is usually used in cases of finding out the predicting the cost of a house. Okay, as the cost of a house can never be negative. Okay, it can always be positive itself, hence we are having this particular max of 0 comma 1 as the function. Okay, that is called as the activation function. Moving forward, so that was the entire crux of activation function. So the entire thing, the entire y dash now becomes g of, that is activation function of the entire hypothesis function. Here we know that in our case the hypothesis function was x1 plus x2 minus 1. This is the hypothesis function. We need to enclose it in some kind of activation function such that we are getting y as the output. Okay, that is the desired output that we are able to get. If you remember the entire thing, okay, so we are having your values of x1, x2 and y as 1 1 1 0 1 0 1 0 0 0 0 minus 1. Okay, this was the entire thing that we were able to get. So what activation function can I apply on this y so that I'm able to get the actual results that we want? Okay, can anyone tell me which activation function can we use? That's right. I don't. I'm not able to. Nalavali. That's exactly correct. Activation function for OR gate will be the step function. That's exactly right. Okay. So the activation function would be the step function. That's correct, guys. Okay. So we will be using the step activation function. Now, what will be the entire like step activation function that we'll be using? Whenever the value is greater than equal to the value of f of x1 comma x2 is greater than or equal to 0, in that particular case we will get 1 as the output. And if it is less than 0, f of x1 comma x2 is less than 0, in that particular case we will get 0 as the output. Let's try to apply this new function, this new activation function that we have created, that is G. This activation function that we have created on the entire OR gate. Okay, so we will get 1. 1 is greater than 0, so we will get 1 as the output. 0 is equal to 0, again equal to 0, we have 1 as the output, so 1. Similarly here also 1. Minus 1 is less than 0, in less than 0 we'll get 0 as the output. Okay, so we'll get 0. For those who didn't knew what step function is, I have discussed right over here. This was the step function, we discussed it just now. Okay, and this is the entire thing. Okay, this is the entire thing, and this is how the hypothesis function and the like activation function work hand in hand to give you the output. That is what we are working on. Okay, very important for you to know, very important, otherwise you will not be able to understand it. Then there is no point of me screaming on top of my voice about what is an activation function and everything. We will now look at much more further details. Currently I'm sharing the attendance link which is available on your screen for the next 30 seconds. Okay, this is the entire link right now. For 20 seconds it will be on the screen. You can just take up like screenshot. Okay, so OR function is also done. I will just go through all the examples so that you guys are able to understand OR functions in a little more depth. Okay, we'll look at some other examples as well so that we can move further on this. If someone is sending the attendance link on the chat section or on the like comment section, that particular person's attendance will also be gone. Okay, that we will not be able to give that particular person who is sharing the link the attendance for that or for any day. Okay, we'll just remove him from the entire bootcamp itself. Okay, this attendance link will be active till tomorrow morning noon. Okay, tomorrow morning noon the attendance link will be active. Okay, so what are my credentials? You can go to LinkedIn and search for me there. My name is Shaurya Sinha. You can just search, like make a Google search for, I don't know if it will come or not. Shaurya Sinha LinkedIn. Let's see what happens. Okay, I think so. This is my profile that came in on the third number. Okay, I need to sign in. Let's just sign in. I will have to sign in to show you my entire. Okay, sign in using another account. Shape your ads. Sign in. Back to linkedin.com. It's just taking so much time. I didn't even open it. Okay, just a second. I have just opened up LinkedIn itself. So let's just search for Shaurya Sinha. So this is my profile. You can easily see about me, where I have studied, where I have done my internships and everything right over here. So like you will be able to understand more about me from there. Okay, so let's continue right now. Okay, so I'll just share this screen again so that we can continue studying. Those people who are just interested in the attendance can leave. Okay, yeah, I'm continuing. I'm just like I just shared it and just I'm moving further. Okay, so that was the entire thing. Okay, now we'll try to understand the different types of machine learning that we have seen. Okay, uh, just wait for a second. Don't worry, it's the same Google form. Okay, the Google form is the same. Don't worry about it. If it is showing day one, it will show day two in just a second. Okay, don't worry about it. It is the like form that you have to fill. Okay, don't worry. Just change it to. Please see the name of the Google form. I've changed it to day 2 right now. Okay, immediately day 2 PACV has been mentioned, so you don't have to worry about it. You can check again. Okay, so let's begin. You can fill up the attendance after this session itself. The link will be open till tomorrow morning noon, so you don't have to worry about it. Okay, so let's continue. Okay, so classification. Yesterday we have seen in supervised learning that machine learning and deep learning is neural networks is basically a part of supervised learning. Okay, so in that we have seen two types, classification and regression. So how will a particular problem be dealt with? For example, probability of that it will rain tomorrow or not. How can we find that? We can find that by taking in inputs like humidity and pressure. We will take in the inputs as that. We'll apply a sigmoid function, okay, because we want to find the probability, so we'll use a sigmoid activation function to give out the probability that it will rain. Okay, so this is something that is very important for you to understand. Okay, then next is regression. Okay, so regression is something in which, so classification is basically like whether it will rain or not, or what is the probability that it is going to rain, something like that. Regression is basically for example, house of a price, house, oh, sorry, price of a house, sorry, price of a house. So that is a regression statement where we have a different range of values that are available to get the like answer. Okay, nobody is going to share the attendance link. If the name is Scott, then in that particular case that particular person will not be getting the attendance and not even the certificates. We will just blacklist him from all the boot camps. Okay, so that is the case. Advertisement and webinars. So we are conducting webinars, we are conducting advertisements, we'll take them as an input and we'll convert it into sales. Sales can be in numbers, of course, like okay, 100 million volumes of sales has happened for us, or like 100 volumes of sales has happened. So that is a particular regression statement. There is no classification in that. Okay, so that is the entire thing that is happening right over here. Moving further, that was just an example for you to understand. Okay, now feed forward. So if someone is asking where is the attendance link, please don't let them know. Okay, because most probably they have not like seen the entire session. You guys are spending so much time understanding so much things, and these people are just coming there and just looking at the attendance and getting the attendance. Just think. Okay, think for yourself. Okay, be selfish sometimes. Feed forward neural networks. Okay, so what is feed forward neural networks? In this, the entire like how can we say it, the entire okay, so you are having your inputs, the data, the entire data, that is the inputs are usually the data. Okay, inputs are data. The data travels only in one direction. You are having your inputs, you are having your neurons, you can have multiple layers of different neurons present. Okay, they are densely connected to each other and so on and so forth. And then you are having your output layer. Here the data is traveling from the input to the output. There is no redundancy of data. Datas are not recurrent, they are going in a single direction. None of the data, none of the output of this particular layer is going back as an input to the first layer. This is not happening. The data is going only in one direction, and this is called as feed forward neural networks. Okay, this is called as the feed forward neural networks. Neural networks have connections in only one direction, yes, that we have already seen, such that the inputs move from such that the data, okay, here it should be data, moves from the inputs to the hidden layers and then to the output. These layers of neurons is called as a hidden layer. Okay, that is the actual termination for them. Okay, they will propagate only in one direction. So you are having an input, the data travels from the input to the network and then to the output. So these are called as feed forward neural networks, just for you to understand that what it is and it exists. Okay, so that is the feed forward neural network. You also have another type of neural networks in which the neural networks, like the output from one layer of the neural network gets sent back inside the first layer as input. These are called as RNNs, recurrent neural networks. Okay, because output from another layer is shifted back inside the first layer or some other layer. Okay, so that is called as recurrent neural networks. That is beyond the scope for this particular bootcamp. We have conducted some bootcamps on RNNs as well in the past, but that was just for a particular college itself. Okay, so these all concepts exist. There is so much in this. There are Boltzmann's constraints and so much that is available in data science. It's a very vast field for everyone to go into. Okay, so today we have completed a basic understanding of neural networks and deep learning. From tomorrow we are going to start with the theory behind computer vision. It is very important for you, okay, because what we'll be discussing in the next 2 days will 100% determine what you're going to write in your code. Okay, so okay, okay, so any questions for me? I'm like available for the next 5 minutes. I can answer some questions. Is AI and ML a subset of data science? No, data science is altogether another. Like for example, how can I explain it to you? For example, you are having physics, okay, and you are having quantum mechanics. So a lot of different like theory and different algorithms and different concepts of physics are being used in data science as well, in like quantum mechanics as well. Okay, so that's the same thing with AI and data science. Data science is where you use data, okay, where you perform different scientific methods on data to gain insights. Okay, so in that you use machine learning and everything as tools. Okay, the machine learning are tools that you use in data science. Are you able to understand that? It's not a subfield. There's nothing like a subfield of data science is machine learning. AI ka subfield is machine learning, not for data science. Okay, data science has tools, different tools like AI, algorithms, machine learning, statistics, probability, and many other tools are being used. Okay, how we'll get the slides? The slides will be put up on the WhatsApp groups and the Telegram channel today. Okay, there's a lot of questions. I'm not able to see all of them. I will try my best if I'm able to answer any of those questions. Okay, just please pardon me if I'm not able to answer your question. Okay. Okay, what can we do after working on data analyst internship at your platform? That is totally like we'll be answering that there. You don't have to worry about it. Is 10th maths enough to learn this? Of course, 10th maths is more than sufficient to learn this. Yes, you will have to learn a little bit of mathematics again, but yeah, that is something that can be handled very easily. Okay, the project you will be making along with me, whatever I will be coding, you will be using the same code to make your project. Okay, so you don't have to worry about it. So for those who are in BTech or BE or in like similar branches, okay, not in like MS or MTech or like PhD, for data science you are having very limit in good like in good companies itself. Like I'm talking about MNCs. In that particular aspect, you are having your data analyst as the main position that is available in data science. Okay, there are other positions as well. For example, machine learning engineer is there, data scientist is there, data engineer is there, data system designer is there, then you are having your data analyst, and so on and so forth. There are so many different job opportunities. But for a fresher who does not has any experience, the only possible way to make it into data science is as a data analyst. A data scientist is of a reputed company are usually at least a MS holder, not even MTech, at least an MS holder from a reputed college in US or UK. Okay, only then you will be able to become a data scientist. Okay, so for those who are telling you that okay, we will become data scientists in just 30 days or so on and so forth, they are just telling you lies. We are working in the industry, we know the actual truth. The best that you can do is as a data analyst. Yes, a data analyst is paid more than a web developer, they are paid more than a particular software engineer, almost 1.5 times more at least. Okay, so yes, data analysts are paid more. We will be joined by Rahul Halalka, who is a upcoming data analyst at Goldman Sachs. We'll also be joined by Parag Mittal, who is an upcoming SDE intern at Microsoft. Okay, so they will be able to tell you guys in a much more depth. I myself am a data analyst, so I know, but like I think so you will be like very happy to like just uh, talk with them as well. Okay. Job package, I'm not disclosing it, but yes, it's a lot. I'm very happy with it. Okay. Yeah. Cybersecurity in India, currently the job opportunities available in cybersecurity are very limited in India. Like there are like I, so less that you can literally count on your fingers. Like that many job opportunities are available in India related to like cybersecurity, a good paying job. I'm not talking about something that you're doing as a hobbyist, finding bugs and everything. Okay, that is something that is just like a business. In a month you can find bugs, in the next month you will not find any bugs. In that particular case, you're not earning anything. So the most safest possible method to go forward would be either with just SDE, okay, or web dev or a data analyst. These are the only three things that are having job opportunities in abundance in India. Even blockchain. So we'll be joined by Devesh Vishwakarma as well. He's a blockchain expert at Reliance. So that is he had already interned at Reliance as well. So he will be able to tell you about that as well. Okay. Mhm. Okay, so there are a lot of questions. Just like I need to stop and just look at some of these things. Okay. So, for example, mhm, ethical hacking. Again, ethical hacking is into cybersecurity itself. No jobs are available in India. Of course, if you are in foreign, then maybe there are jobs. But I'm not a foreigner. I'm an Indian. I can only tell about Indian students itself. Okay, blockchain also very less amount of jobs, more than like of course like more than other branches, but blockchain is also a very like it has started going right now. So it will take at least 5 6 years to get blockchain established and to have jobs in that. Yes, we will be using TensorFlow for our project. Okay. Okay, so why are job secure cyber security jobs less in India? Because Indians are usually 10 years behind US, like Indian companies, and they have not yet paid much more focus upon cyber security in India, hence less number of jobs. All these guest lectures will be like conducted in the last 2 or 3 days of the boot camp. Okay, so let's keep it till this itself. Tomorrow we'll meet again, and then we'll be discussing more. We'll be continuing and starting with computer vision so that you guys are able to understand. Again, it will be very helpful for us if you are subscribing to the channel and liking the video. It really motivates us to bring you better content so that this content is available for free for everyone. We just want to make a good community from this. Please join the Telegram channel, or the like you can go to our Instagram account Shape AI. There you will be able to find good questions related to data science interviews. You will be able to find good posts on many different things. I will share it with you tomorrow as well. The link is in the description. You can go and check. Okay, so it really helps us a lot, and we'll try to bring in as much as we can. Okay, thank you so much for being there with me. Okay, tomorrow we will get started with computer vision. Okay, good night.